This video is on solid revolution, and I have this yellow region right here, and I'm going to revolve it about the y-axis, and I want to find the volume of the solid revolution. And so here, this is our yellow region again. It is bounded by the line x equal to 1, the line y equal to 5, and the graph y equal to 0.2x minus 1 squared. And we're going to revolve this yellow region right here about the y-axis. So this is the y-axis right here. And so we revolve this yellow region about the line, the y-axis. Then we're going to get a solid with the hole in the middle. And so we see that the hole right here in the middle is just a cylinder. And so to find the volume of this solid without the hole, then what we can do is find the volume of the entire solid with the hole and then subtract from it the volume of this cylinder right here. And so here's the solid without the hole. And so what we want to do is find the volume of this solid. And so again, we're going to divide this solid here into many slices and then find the volumes of the slices and then add them together. So for example, here I divided the solid here into 10 slices. The solid runs from y equal to 0 up to y equal to 5. And so if we divide the solid into 10 slices, then the thickness of each slice will be a half, or 0.5. Because the distance from here to here is 5, and dividing by 10, we get a half. And the thickness here, let's denote it as delta y. And then if we divide the solid into 20 slices, then the thickness of each slice will be 0.25, or delta y will be 0.25. And then here I divided the solid into 40 slices, and so the thickness of each slice, or delta y, is 0.125. And then here I divided into 100 slices, and the thickness of each slice will be 0.5. And then eventually what we want to do is divide the solid into many slices. Here's 100,000 slices, million slices, and then to get the exact volume, what we need to do is divide the solid into an infinite number of slices. And so now let's go back to the case where I divided the solid into 10 slices. Then the first slice is going to be between y equal to 0 and y equal to a half. And then the midpoint between 0 and a half will be 0.25. The second slice will be between y equal to 5, 0.5, and then y equal to 1. And then up to the last slice, which is slice number 10. And slice number 10 is going to be between y equal to 4.5 and y equal to 5. And so the midpoint is going to be 4.75. And then to find the volumes of the 10 slices, we can estimate them with the cylinders. And so for the first slice, I'm going to estimate it with this cylinder right here. And this cylinder also has the same thickness as the slice. And so the slice has a thickness, or delta y, of a half. And so the cylinder here is also going to be a half. And so the thickness of the slice of this cylinder, or the height of the cylinder, will be a half. And then we also need the radius for this slice right here. And so to get the radius, what we need to do is find the distance from the y-axis to the graph. to figure out what this radius is, we need to go back to the this function right here, which was y equal to 0.2 x minus 1 squared. And so here we're given a y, the midpoint, of 0.25. Then we need to find this, the corresponding x. So here the graph, the function is y equal to 0.2 x minus 1 squared. Multiply both sides by 5. And so solving for x, and then this is on the right side of the y-axis, so we only need a plus instead of plus and minus here. And so we get x equal to the square root of 5y plus 1. And then I'm going to write this as x is equal to g of y to indicate here that x is a function of y, or x depends on y. And so when y is 0.25, if we put 0.25 in here, and so we get the square root of 5 times 0.25 plus 1. And that will give us the radius. That will give us the corresponding x. And so in this case, the radius is going to be 2.11803. So once again, to get this 2.11803, we're going to go to this function right here. In the place of y, we put 0.25 and then simplify, and we get 2.11803. And so for this cylinder right here, the height or the thickness of the slice is 0.25. The radius is 2.11803. And so the volume of this cylinder, which is pi times the square of the radius times the height, is going to be 7.046699. So for the second slice, which is between y equal to 0.5 and y equal to 1, so the midpoint is 0.75. So this is 0.75. And then we need the radius of this cylinder right here, which is the distance from here, from the y-axis to the graph. And so to figure out what this distance is, we need this point right here. And so to get this point, we go back to the equation x equal to the square root of 5y plus 1. So here the y is 0.75, so we put 0.75 here, and then simplify. We'll get 2.93649. So the volume for this second cylinder is going to be pi times the radius, in this case is 2.93649 squared, times the height of the cylinder, or the thickness of the cylinder. In this case is 0.5. And then the volume of the second cylinder is going to be 13.54495. And then here's the third cylinder, the fourth, the fifth, and then all the way up to the last one, which is the 10th cylinder. And if we add the volumes of the 10 cylinders together, we'll get 317.04699. So this is the sum of the volumes of the 10 cylinders or the 10 discs. And then summation notation, we would write it as I running from 1 to 10. And then this is pi. This is times the square of the radius, and then times the thickness of each slice, or the height of each cylinder. It will get 317.04699. Instead of 10 discs or 10 cylinders, if we divide the solid into 20 cylinders, And then add the volumes of the 20 cylinders together, we get 316.876. And here's the summation notation. And this is for 40 slices, and this is the volumes for the 40 cylinders. And then here's the volumes for 100,000 slices. So right now we're dividing this cylinder right here into 100,000 slices, and the volumes of the 100,000 cylinders will be 316.777,259. And for 500,000 slices, we'll get 16.777,259.26. And for 1,000,000 slices, then we get 316.7725924. And as I mentioned earlier, if we want the exact volume, this is still only an approximation, and so to get the exact volume for this solid, then we need to allow n to run to infinity. And so this right here, this infinite sum, it will give us the exact volume. So let's go find the this infinite sum right here. Once again, this is the volume, approximate volume when we use 10 cylinders. This is for 40 cylinders, for 1,000 cylinders. And this is for 2,000 cylinders, 5,000 cylinders, 10,000 cylinders, and then 50,000 cylinders. This is 100,000 cylinder, 500,000 cylinders, and 1,000,000 cylinders. And here we want n, we want to let n, or the number of cylinders, or the number of subintervals, approach infinity. I running from 1 to n, with n approaching infinity. And so this is the case where we divide the solid into an infinite number of slices. And so this limit here, when it exists, we defined it as the definite integral from 0 to 5, and here's the pi, and then this is the radius function, and then this is dy. And then the 0 and the 5 here, if we go back to our original graph, at the bottom here we get y equal to 0, and then here we get y equal to 5. So this is y equal to 0, this is y equal to 5. So that's where the 0 and the 5 come from. And then for this particular example, recall that the original function was written as y equal to 0.2x minus 1 squared. And then writing x in terms of y, we get x equal to g of y equal to the square root of 5y plus 1. And so in the place of g of y, we have the square root of 5y plus 1. And then simplify here, we get 5y plus 2 times the square root of 5y plus 1. And then this part here, I rewrote it as 2 times the square root of 5 times y to the 1/2. And then find the antiderivative of each term. We get 5/2 y squared. And then 2 times the square root of 5y. And then for the y to the 1/2, the antiderivative be 2/3 y to the 3/2. And then 1 antiderivative is 5. Evaluating from y equal to 0 up to y equal to 5. So when y is 5, this is what we'll get. And then when y is 0, we just get 0. And then simplify here, we get 605 over 6, and then times pi, which is 316.777,259. if we compare this number here, this value here, with the case where we divide the solid revolution into a million slices, we will see that the two values are very close to each other. And so once again, here's the case for a million slices. It's the Y316.77725924. We can see that it's very, very close to this number right here. And so the exact volume for this solid revolution is 605 over 6 times pi. And so in summary, what we want is the volume of the solid with the hole. And so the hole is just a cylinder. So the volume of the cylinder is pi times the radius squared times the height. The radius of this cylinder is just 1. And then the height of the cylinder is 5. So the volume of the cylinder is 5 pi. So the volume of the solid with the hole is 605 over 6 times pi. And then subtract from that 5 pi, we get 575 over 6 times pi. So the volume of this solid with the hole is 575 over 6 times pi. And that's the end of the video.